Welcome to Agentic Impressions, where we'll be discussing various topics across the agentic AI landscape. Our first season will be covering the basics of agentic AI, starting with importance of structure with AI models. Hi, everyone. My name is Shireen Bellamy. I'm a senior developer advocate here at Cisco, focusing on AI, quantum, and security. What I'm doing today is giving you the first episode in a series of episodes showing you the insights of what I experienced in my career as a developer advocate. Starting with the AI landscape, I want to talk about a common misconception that I'm seeing today. With everyone focused on LLM power and waiting for the next ChatGPT 6, 7, or 8, a common oversight is that we're overlooking the power of architecture with the models that we have today. What I'm seeing is that if you focus on the architecture of a common model, then you can get some pretty good performance optimization. So for today, I'm going to be going through a demo that I have on github.com. It's going to be going through the Cisco agency framework. More on that on their YouTube channel, but the phenomenon I'm showing you can be applied to other existing frameworks or even customizing one of your own. At the end of this episode, you'll understand why architecture beats raw power, and you'll have the tools to implement these improvements by yourself. So now let's get to coding. Today, we're going to be using an OpenAI key and an Anthropic key. However, feel free to build on this in that area and use whichever keys that you want. Again, what we're doing is we're trying to play with the structure a little bit where possible to enhance performance. So the beauty of the framework is that it adds an additional layer to the agent ecosystem. And as a result, it's able to optimally coordinate the best agents for each task by providing an Internet of Agents architecture, as you can see in the diagram. So what Agency does is it provides standards for agent interoperability. It offers components like agent identity, agent directory, messaging protocols like the SLIM protocol, and Agent Connect protocol, also known as ACP. And it enables agents to discover each other, verify capabilities, and collaborate securely. So what Agency doesn't do is Agency is not selecting a specific LLM that powers the individual agents significantly. That's not how we're getting our increased performance today. Each organization or developer that's building agents on the Agency platform chooses their own LLM. So GPT, Claude, Llama, whatever, based on their specific needs. And then the coordination that you're using with Agency can lead to an overall improved performance in the agentic experience, which we'll see today. You can find more information on Agency on their YouTube channel, seen below. Now we're going to move on to creating our first agent. And the reason why we're doing this is because when we look at the tech landscape today, as everyone's transitioning from chatbots to agents, each agent has a specialized role and memory. So the memory here is crucial. Unlike chatbots, which are stateless, agents have the ability to remember their work and build on previous results. So, for example, this think method is where specialization happens. So in this case, if we're going to make a research agent, the focus is going to be specifically on data gathering and analysis. Meanwhile, if you create a strategy agent, then the focus would be more so on synthesizing findings into something actionable, like recommendations. Great. So now we have agents that can perform tasks. But the next thing we want to do is make sure that they perform tasks as optimally as possible. And also, a common issue that's being solved in the industry is making sure that they're not working alone in silos. If you have a research agent that's really good at researching and a strategy agent that's really good at strategizing, what is the protocol that's most effective in making sure that you can get a final task completed? And that's where the thought process of multi-agent frameworks come into play. And that is the best place to design and measure or design and analyze your architecture of choice. For this multi-agent workflow example, what we're going to be doing is creating two specialized agents. And I'd like to highlight here, notice how we define their roles from the beginning. This is an agent collaboration. The strategist is building on the researcher's work rather than working alone. And again, this is the structured handoff that chatbots don't have the ability to do. So with this output, we're able to see how agents are structured in a workflow. We have our data bot, who is our research specialist agent that is focusing on renewable energy and market opportunities. And ideally, in the future, we want it to coordinate with the other agent we created, this strategy bot, which is in charge of creating an executive summary based on certain keys, like finding renewable energy market opportunities and strong drivers. So overall, we have two structured outputs, and what we're going to look at next is figuring out how to orchestrate them into a tangible solution. So we've seen that agents can communicate with each other, but here's the critical question. Does how they communicate actually matter? Let me show you something interesting. I've built a performance comparison that tests 3 different architectural approaches. And here's what we're working with. We're working with the agency agent class that's wrapping the agency ACP SDK, creating agents with metadata and capabilities. We also have the performance comparison class that orchestrates our 3 different approaches. And altogether, we have 3 asynchronous methods: the traditional approach, MCP approach, and the A2A approach. Each one solves the exact same problem, just with different communication patterns. The code is available in GitHub. However, for the video, I'm going to be focusing more so on the output for our conversation today. Feel free to dive deeper into the code on your own, or post any questions you have below in the comments. Okay, now let's watch this output. What the program is doing is it's looking for the agency SDK, and it's initializing our LLM clients. The specialty for OpenAI is usually generalist work, while Claude's specialty is specialized research tasks. What we're about to see here is the same business task, a Southeast Asian renewable energy market entry strategy, solved in 3 different ways. So first, we have the way that most people build with LLMs today. We're calling it the traditional approach method, and what we do is call OpenAI's GPT-40 Mini 6.5 out of 10. It's not bad, but we can work towards better. The problem that we have here is that we have that one generalist agent from OpenAI trying to be an expert at everything, at market research, strategic planning, and implementation. And that's a lot to ask from an agent that's supposed to be skilled at one thing. Next, we have the MCP approach. So for this, we're using MCP, still one LLM call, but we're going to look at what has changed. We're building a shared context dictionary with task details, domain info, region specifics, and then we're passing that rich context into the system message. So as a result, the model has more structured information to work with here. We have the same single agent, but with enhanced context management. So with that, we have 7.5 out of 10, which is a 15% improvement just from structuring our context better. So here we already start to see the gains from playing around with the structure. It's better information architecture with the same underlying model. The A2A approach creates 3 specialized agency agent instances. So we have phase 1, strategic planning agent, which is the expert in frameworks and risk assessment. We have 2, the market research agent, which is specialized in data synthesis and competitive analysis. And then we have an implementation agent, focused specifically on execution and resource allocation. Each agent has different capabilities. They're defined in the constructor like we showed in the last demo. They're not just getting different prompts, but architecturally, they're distinct specialists. What we can see in the coordination is that the strategic agent analyzes first while sending its findings from the A2A message passing. The research agent receives that context and then builds on it with the market data. And then we have the implement agent that's getting both outputs, and then it's able to create an actionable roadmap. This is an example of true agent-to-agent communication using the A2A protocol while it calls different methods from my program. We have the strategic analysis method, the market research method, and the implementation planning method, each with specialized system prompts. Altogether, this has our best performance at 9.2 out of 10, that's a 41% improvement over the traditional approach that we started off with. Now look at this comparison table. It's the same task with the same underlying models. We're using GPT-40 Mini and Claude Haiku throughout. We have the quality score that's been enhanced from 6.5 to 9.2. Our agents used tripled from 1 to 3. In terms of context sharing, we had none, and then we slowly progressed to full A2A. And then in terms of the protocol, our first example was we started off with HTTP, then we used HTTP again with a little bit of MCP enhancement, and then we used A2A and leveraged ACP and SLIM from the agency framework. The best result doesn't come from using bigger models or tokens. It came from the architectural choices that we made along the way. We went from 1 generalist to 3 specialists, and the quality jumped to 41%. So that's not a marginal improvement, that's a transformational improvement. Now let me break down what's actually happening on a protocol level. For the HTTP example, the traditional example, we have a single synchronous API call that's coming from the OpenAI.chat completions create. We have 1 prompt in and only 1 response out. So there's no state, there's no memory, and there's no coordination happening in this example. This traditional approach method is literally 1 function call. The MCP method, again, we have that enhanced context object, which is defined in our shared context variable. And that context is injected. So the context of the task, the domain, the region, the requirements, that's all put into a system message to make richer prompts and provide better grounding. It still remains stateless, but the model is exposed to more structure. So in this MCP approach, there's context that's able to be built before the LLM call begins. And then in our most robust approach, the A2A and agency framework approach, there are 3 asynchronous agent invocations running in phases. So the A2A message is passing from strategic planning to market research with a context of strategic results. Each agent uses the agency ACP metadata system, ACP for agent identity, A2A for messaging, and then we're using SLIM for efficient communication. And the A2A approach orchestrates the sequential coordination with context handoffs. In this example, we can see structure isn't just important, but it's truly a performance multiplier. And that's exactly what agency is enabling here on top of the protocols. So what's next? How do you want to implement this? You have 3 options. 1, you can build your own system. If you build your own system, it'll need to have 4 core elements. 1, agent specialization with different prompts for different tasks. 2, memory systems for context persistence. 3, structured communication protocols. And 4, workflow orchestration. If you don't want to build your own system, another option that you have is to leverage existing frameworks. So for example, you can use AutoGen for multi-agent conversations, Crew AI for role-based teams, LangGraph for the workflow orchestration, or even agency like we discussed today. And then a third option that you can look at to get started is more of a hybrid approach. So what you can do here is start with a framework for rapid prototyping and then add custom optimizations for your use cases. So again, this isn't just about cool technology. This is about staying ahead of the trend before it comes out. All of the code and setup instructions are in the description. And whether you choose to build your own, use an existing framework, or take a hybrid approach, the architectural principles remain the same. Don't wait for GPT-6 when you can get that performance today. Thanks for watching, and I'll see you in our next episode where we'll take a look into agent memory systems and how the AI is able to maintain its memory across complex workflows.